Hi, I'm Rowan Miller. Let's write an application that performs data access using Entity Framework Code First. Our application is going to target a new database, so we're going to take advantage of the Code First feature that will create a database for us. I'm going to use Visual Studio 2012, but you can also use Visual Studio 2010. Let's create a new project, a console application, and I'm going to call this CodeFirstNewDatabase sample. Now that we have a project, let's go ahead and define a set of simple domain classes. I'm going to use the familiar blog and post model, where a blog has many posts and a post belongs to a blog. You'll notice that these are very simple classes that have no dependencies on Entity Framework. These are often called POCO classes, which stands for Plain Old CLR Object. In my classes there are two different types of properties: scalar properties such as blog ID and name, and navigation properties that define the relationships between my classes, such as blog.posts and post.blog. I'm adding the virtual keyword to the navigation properties. This enables an Entity Framework feature called lazy loading. This feature means that Entity Framework will automatically query and populate the contents of these properties whenever I try to access them. Now that we've defined our classes, let's use Code First to perform data access. To do that, we're going to need to add Entity Framework to our project, and I'm going to do that using NuGet. Within the Manage NuGet Packages dialog, I'm going to select the Online tab, then the Entity Framework package and click Install. Now that we have Entity Framework in our project, we can go ahead and define a derived context. We're going to call ours blog context. This context derives from the DB context type, which is a base type from Entity Framework. The context represents a session with the database and allows us to query and save data. On the context, we define a property that is a DB set for every type in our model. This DB set allows us to query and save instances of those types. Now that we've defined our context, let's go ahead and perform some data access using it. Whenever we use a context, we need to wrap it in a using statement to ensure that any resources are freed up when we're finished with the context. Let's prompt the user for a name for a new blog. Once we've read this name in, we can create a new instance of the blog class with the name assigned. We can then add that instance to the blogs property on our context. Remember, that's a DB set of blog. Once we've done that, we can save changes, which will push all pending changes we've made to the context to the database. In this example, that is a single insert for the new blog. Let's also write a link query that selects all blogs from the database ordered by name. We can then for each over the results of that query and write out the name of each blog to the console. Let's go ahead and run our application and see what happens. As expected, we're prompted for a name for a blog. I'm going to enter ado.net blog. We then see a list of all blogs from the database printed out to the screen. At the moment, that's just the single blog we just inserted. Now, one thing that's interesting is we didn't do anything to set up a database. If I go and look at my local DB instance, I'll see that CodeFirst has actually created a new database for me called CodeFirstNewDatabase sample.blog context. That's the fully qualified name of our derived context. Looking inside the database, I'll see that there's a blogs and a posts table, and the columns in those tables line up with the properties that we defined on our domain model. What CodeFirst is doing here is using a set of conventions to work out what the schema should look like based on the classes. Rest assured, there's plenty of opportunity to change the conventions if you don't like what it's doing by default. Now, Visual Studio 2012 comes with LocalDB, whereas Visual Studio 2010 came with SQL Express. So if I had SQL Express installed, as would be the case if I was using Visual Studio 2010, CodeFirst would have created the database on SQL Express rather than LocalDB. Now, as our application evolves over time, we're going to need to make changes to the domain model. And that in return is going to mean we need to make changes to the database schema. To do this, we're going to make use of a feature called CodeFirst Migrations. To start using CodeFirst Migrations, I'm going to open Package Manager console and run the Enable Migrations command. This is going to look in my project, find the blog context, and go ahead and enable CodeFirst Migrations for the blog context. Doing this has added two things to my project inside the Migrations folder. The first one is to add a configuration class. This class contains all the configuration and settings for migrations for our blog context. We don't need to change anything in here at the moment, but this is a place where you can change the folder that migrations are added to, register providers for third-party databases, or specify seed data. The other thing it added is an initial create migration. It added this because we've already created the database and applied a set of changes. Remember, we've already created the blog and post table. If we look inside this migration, we'll see some code that represents creating that blog and post table in the database. CodeFirst Migrations has also recorded in my local database that this migration has already been applied. Now that we've enabled migrations, let's go ahead and make a change to our domain model. To keep things simple, I just want to add a URL property to the blog class. Once I've done that, I can use the add migration command to go ahead and scaffold those changes into a new migration. Add migration allows me to give a name to the migration. When I run this command, I'll see that a new migration appears in the migrations folder and is open for me to view. If I open this new migration, I'll see some simple code that has an upgrade and a downgrade method that says to add the URL column on the way up and to drop it on the way down. Now that I have a new migration, I can use the update database command to go ahead and apply any pending changes to the database. When I run this command, it's going to look in the project and see my two migrations. It's going to look in the database and see that the initial create migration has already been applied, which means it just needs to go ahead and apply the add URL migration. With this done, if I go back to the database and refresh the blogs table, I'll see the URL column is now present. So far, we've just relied on CodeFirst conventions to interpret the shape of our classes and to decide what the database will look like. But there are going to be times when your classes aren't going to follow what CodeFirst is expecting, or you want to change what the database looks like. There are two options for doing this: data annotations and the Fluent API. Let's take a look at data annotations. I'm going to go ahead and add a user class to my model. And one thing that's going to be a bit different about this user class is instead of exposing a property called user ID, which is what CodeFirst expects, I'm going to have the primary key called username, and it's going to be of type string. I'm also going to add a DB set to our derived context so that the users are included in our model. With this done, if I go ahead and run add migrations, you'll see I get an exception because CodeFirst can't work out which property should be the primary key for our user. Now, using data annotations, I can rectify this by adding the key annotation to the username property. You'll see that the annotations are defined in the system.componentModel.dataAnnotations namespace, so I need to add a using for that. With that done, I can go ahead and rerun the add migration command, and this time an add user migration is successfully added to the project. If I then go ahead and run update database, we'll see that that change is applied to the database. And if I go ahead and refresh the tables, I'll see the new users table is there with the username column configured as a primary key. Now, data annotations are a great simple way to override CodeFirst conventions. The second option is the Fluent API. The Fluent API is a bit more advanced and covers everything that can be done with data annotations and a little bit more. To explore the Fluent API, let's say that we want to change the column that the display name property of users is mapped to be called display_name. To use the Fluent API, I override the onModelCreating method inside our derived DB context. I start by identifying the entity that I want to configure. In our case, that's user, and from here I'm going to identify that I want to configure the display name property. Now, there are lots of things I can configure for this property, but I want to change the column name that it's mapped to, and change it to display_name. With that done, I can go ahead and add a migration. You'll see here the up method renames the display name column to display_name, and the down method renames it back the other way. Let's use update database to apply those changes. And then refreshing the columns in the users table, I can see the display name column has been renamed. So far, we've seen how to create a CodeFirst model, how to have a database created from that model, and then how to change that database using CodeFirst migrations as our CodeFirst model changes over time. We then saw how to override the conventions that CodeFirst has using both data annotations and the Fluent API.